In this particular problem, our aim is to find out the first 6 natural frequencies as well as the mode shape for this airplane wing. See here, it is a simple airplane and we are going to consider this particular wing and coming to the boundary condition. See, this particular one end of this wing is attached to the cockpit and the other end is going to be free. And the material with which of particular airplane wing is made is titanium alloy. And our aim is to find out the first 6 natural frequencies and mode shapes using Ansys workbench. And performing a model analysis on the aeroplane wing, we have opened Ansys workbench. In Ansys workbench, go to model tab and drag it and place it on the project schematic. Now specify the material, go to engineering data. This particular wing is made up of titanium alloy, and this titanium alloy is a material that is already available in the engineering data library. So go to engineering data sources, select general materials library and find out the titanium alloy from the list. Add it. The book which is shown here represents that this particular material is available for our present analysis. Now go back to project, then right click on the geometry cell, select import geometry and select this model. Now double click on the model cell and here is our model. Now to go to the geometry branch and expand this branch and select this model and change the material assignments from structural steel to titanium alloys. Then go to mesh, right click and generate mesh. Go to the model and if we go to the environment toolbar, here see lot of types of loads are not present. They are not visible. So what does it mean? Depending upon the type of analysis we are going to perform using Ansys workbench, availability of different loads and support will be there. Here in supports, select fixed support and select this phase and apply. And once you apply, see here it is showing that this particular phase has fixed support. Now in model analysis or free vibration analysis, we don't have any loads to apply on the object. We have only the constraints that are to be applied to the object. So I have applied the required constraints. Now go to solution branch, right click and press solve. When we click on solve, it is going to find out the natural frequency values and also the mode shapes values. So here once the solution is done, in the graphics window, see there are some bars that are present the value of the natural frequency. And there is a tabular data here which shows the mode number and which shows the frequencies of vibration. So what it means is in the mode 1 it is going to vibrate at a frequency of 106.23 and unit are in hertz. So what happens? So in the mode number 1 or in the fundamental mode, this wing is going to vibrate at a frequency of 106.23. That means if any working frequency is nearer to this 106.23, what happens? The natural frequency of the wing and that working frequency are going to coincide, and this may lead to the resonance phenomena, which leads to the ultimate failure of this particular wing. Likewise, we have found out 6 modes and 6 different frequencies. Now what we need to do is we need to select everything and then right click on them and select create mode shape results. Now we have known what are the different frequencies at which this particular wing is going to vibrate. But by understanding the mode shapes, we can predict in which way the vibration will occur at that particular frequency. For that purpose, I have selected this option and I am going to right click on the solution and evaluate all results. So once I evaluate all the results, see if we click on the total information once, so what happens? There are some displacement values that are represented here. So remember one thing, whenever you perform a model analysis or free vibration analysis, you get some deformation results. They doesn't mean anything. You should not be relying on these values. So whatever the results that is going to be calculated in a model analysis, we will need to ignore. So now animate the mode shape. So what happens? It is going up and down. From this, what can we understand? If there is a frequency of 106.23, this thing is going to be vibrate in the up and down direction. Or with, if we come to the reference of the global coordinate system, this is going to be vibrate in y-axis. Then coming to natural frequencies, number 2, and play the animation, see it is vibrating in the x direction. Then coming to the third one and play the animation, see here what happens. Instead of moving up and down or sideways, it is moving in a form of a wave. So what happens at this particular frequency, this particular type of deformation will occur in the wing. Likewise, we can check for the fourth one and play the animation. See, this is a twisting torsional mode. At fifth and play the animation, see here it is a mixed mode of vibration, or we can call it is a mixer mode of vibration. Then sixth mode and play the animation, also there are some mixed mode. See here, in addition to this particular translation, it is also having some sort of bending and other sorts of things. So this is how we can perform model analysis on objects by only applying constraints, and we can find out these frequencies and mode shapes in which the body is going to be deformed.